Welcome back to Chemistry Exams Prep. This is Dr. Kulbhushan. I am back again with an interesting question for you. This question is asked by Miss Lauren from the State University of New York. In this question, she asked about the classification of these species as non-aromatic, aromatic, or anti-aromatic. So we have a bunch of species. Some of them are neutral like A and B. Some of them are charged like G and H. In species J, there is two negative charges. So to answer the question and to classify these species, we need to review the definitions of aromatic versus anti-aromatic compounds. So the aromaticity was explained by Haeckel, and there are four conditions that need to be met in order for a compound to be classified as aromatic compound. So those four conditions are, the first one is that the species, it must be planar. That means that all the atoms in the compound must be sp2 hybridized. The second condition is that the species need to be cyclic. Non-cyclic species are not aromatic at all. The third condition is that the atoms must be conjugated. There must be conjugation so that the electrons can move around over the whole molecule. And the fourth condition is that the species must have 4n plus 2 pi electrons, where n is a number which can be 0, 1, 2, 3, and so on. So now, what is anti-aromatic? So anti-aromatic is similar to aromatic in three conditions. Anti-aromatic compounds are also planar, they are cyclic, they are conjugated, but the pi electrons here are 4n. Instead of 4n plus 2, there are only 4n pi electrons. Again, the n can be 0, 1, 2, 3, and so on. So now, what is non-aromatic? So non-aromatic is a species that has one of these four conditions missing. It may have one condition missing, or it may have more than one condition missing. So let's have a look on the examples now and classify the species. So if we have a look on compound A, the oxygen here has two lone pairs of electrons, and it's a 5-member ring because the oxygen is not the carbon. So these compounds are known as heterocyclic compounds. So it's got 4 carbons and 1 oxygen atom. Now, how many pi electrons does this have? This is called the furan. So now we know that the alkenes are sp2 hybridized. So these carbons are, 4 carbons are sp2 hybridized. So they fulfill the requirement of being planar. However, the oxygen, if you have a look quickly on the oxygen, it seems like it has 2 lone pairs of electrons, and the fact is that furan is aromatic. Then why? Because there are 8 electrons here total. But the fact is that the one lone pair of electron is in sp2 hybridized orbital, and the other lone pair of electron is in the p orbital. So the one that is in p orbital is what takes part in the conjugation in the resonance movement of electrons, and hence the compound A becomes aromatic. So compound A is aromatic. We will call aromatic by A. Similarly, if we have a look on compound B, it also got a heteroatom in the ring. This one is called the pyrrole. So again, this nitrogen here is sp2 hybridized, and so it's got 6 pi electrons now, and this is planar cyclic and it has conjugation with 6 pi electrons. Therefore B is also aromatic. Now compound C is called N-methyl imidazole. So now this nitrogen is similar to what we saw in pyrrole, but it also got another nitrogen here. And now this structure is planar, it's cyclic, and the atoms are conjugated for pi electron movement. Now the question is, how many electrons does it have? So it seems like it has 2 pi electrons in each bond between carbon-carbon and carbon-nitrogen, and it also got 2 lone pairs of electrons on the nitrogens that are the part of the ring. So now if it is not sp2 hybridized any atom, then that would be a problem for the conditions. However, in this case all the nitrogens are sp2 hybridized. This is also sp2 hybridized nitrogen. The lone pair that is on this nitrogen is not in the p orbital, so it is in sp2 hybridized orbital. Therefore that does not count towards the 4n plus 2 pi electrons. So now as we see, it's a planar molecule, it's cyclic, it's conjugated, and it's got the 6 pi electrons. Therefore C is also aromatic. Now compound D, this is a derivative of pyridine. Similarly, the nitrogen here, the lone pair is in the sp2 hybridized orbital, and p orbital is what is taking part in the conjugation. Therefore D is also aromatic because it's planar cyclic and it's got conjugated 6 pi electrons. The oxygen here also has 2 lone pairs of electrons, but they do not take part in the resonance in this structure. Next species is the cyclopentadiene. So cyclopentadiene got 1 carbon that is actually sp3 hybridized, and the geometry of sp3 hybridized carbon is tetrahedral. So the molecule is not flat. It cannot undergo the conjugation, the resonance movement of pi electrons, and therefore species E is not aromatic. So let's call them as Na for non-aromatic. Now the next species is Homo sapiens. Now the question is, can Homo sapiens be aromatic? The answer is that they are non-aromatic because they do not fulfill the 4 conditions of Haeckel's rule of aromaticity. Therefore that is not aromatic. Next species G here. So G has 2 pi electrons and it's got a positive charge on the cyclopropyl. This is cyclopropynyl cation. So it is planar. The second condition is it's cyclic, it's got the conjugation, and it has 4n plus 2 pi electrons, where the value of n is 0 here. Therefore G is aromatic. Next one is species H. So H is planar, it's cyclic, and it has conjugated 4 n pi electrons, and therefore this one becomes antiaromatic. Now the species I, this one is again antiaromatic because it is planar, cyclic, and it has 4 n conjugated pi electrons. So this is also antiaromatic. Now species J. So this species has 2 carbon, those are clearly visible as alkene carbon as sp2 hybridized. But these 2 carbons are also sp2 hybridized. So therefore this species J is also aromatic, and the reason for that is because again it fulfills the requirement of Haeckel's rule of aromaticity. It's got 6 pi electrons, and it's planar, it's cyclic, and there is conjugation. Therefore J is aromatic. Now species K. K has 4 n pi electrons. This carbon here is all right. This one has sp2 hybridized orbitals, but because the number of pi electrons is 4, where the value of n is 1 here, so therefore this one is also antiaromatic. Now the last species here is L. So L is actually this got 6 pi electrons. It's planar, it's cyclic, therefore the L is aromatic. All right, that's it for now. Thanks for tuning in. Bye bye.